Okay, so I am here to show you guys a quick demo that I got running on my Mac. I have a MacBook Pro. Uh, it has a Core 2 Duo. It's not super fast. It's not super slow. It's running the NVIDIA GeForce 320M, as you can see here. Anyway, I've been exploring OpenCL and parallel computing for some time now, and I think it's the way of the future because it enables even a relatively low power computer like mine to do some really awesome calculations in real time using many parallel processors, which are inside your graphics card. That's actually how your graphics card works. It's called single instruction, multiple data, which means basically you're turning your computer into a supercomputer. In fact, you've got a supercomputer installed. It's called your graphics card. So, depending on the power of your graphics card, obviously, you're going to have more or less power to do this kind of thing. Anyway, as you can see, it's not a great graphics card. 256 megs of RAM, NVIDIA GeForce 320M. Not exactly sure how many shader pipelines or whatever it's got. Not too many, but it's all right. I could play StarCraft at low settings pretty smoothly on it. So anyway, let me get to the good stuff. I discovered this tutorial on the website of NJ. That's just enja.org. He's got some cool stuff, and one really neat library that he demonstrates is called PyOpenCL, which actually requires PyOpenGL. GL stands for Graphics Library. CL stands for Computation Library, as far as I know. Something like that. So it actually, OpenCL, you may have heard of CUDA by NVIDIA. That's a system-specific type of parallel computing tool. OpenCL is cross-platform, which means you're not going to have all the little NVIDIA special stuff. It's not that huge of a difference, basically, but OpenCL, you can run it in parallel on your CPU if you've got a quad-core. Let's say even if you've got like a Xeon or something, you know, dual quad cores, that kind of thing, hyper-threading, whatever. It's going to take advantage of your system's parallelism. In this case, we're going to run it on the graphics processor. So, Python is a really cool language because it's kind of slow, but you can have it harness these really powerful libraries that are really fast because they're written in C and C++ as well. So, I went through some rigmarole to get this working. I actually had to download from Kronos. I had to follow this guy's instructions down here because I'm running on a Mac, which I believe doesn't have the latest version of OpenGL. I'm running 10.6. So anyways, yeah, a lot of people were having this problem where they wouldn't actually do CL, GL memory sharing. So I did what this guy said, Steve, and it worked. I just downloaded CL extension.h from Kronos, put it in user include CL. Now there's a handy shortcut for that. Just open Finder, Command-Shift-G. There it is. So I just made this folder, put CL extension.h in it. I had to authenticate in order to modify this folder because it's one of the system libraries, or system folders. So I made sure to use capital letters CL. I don't know if it matters on Mac, but it does on Linux and Unix variants. Put in CL extension.h right from the Kronos website. Then I had to install PyGL and PyCL using configure.py with the option CL enable GL. It's all right here. So anyways, let's get to the good stuff. I'm just going to open it up. Here we go. Now there's also another command you need. I don't know if you need it for PyOpenGL. You need it for PyGLit or Piglet. That. Piglet is faster than PyOpenGL, but that's not what PyOpenCL uses. PyOpenCL uses PyOpenGL. So I had to jump through a whole bunch of hoops to build that on my machine, but it wasn't too hard. Just do a bunch of Googling, you'll get it. So we're in our part 2 directory, and you can see there's some files here. I'm just going to run a little batch file. Oops. This command simply causes the default Mac Python to run in 32-bit, which for some reason is necessary to get OpenGL working sometimes. Anyway, when I say, I actually have it in my bash profile, so if I just say source py32, that'll run those commands. So now it should be ready to go. So take a look. Python main.py. Boom. Now, as you can see, we've got some pretty cool geometry going on here. It kind of looks like a fountain. This is 3D, real-time, calculating every single one of those particles using the graphics card. That is the power of OpenCL. Now, I believe this is actually using shared memory between OpenCL and OpenGL, which means my computer is actually doing calculations on my graphics memory that you can see happening right now. Those calculations are simple physics. As you can see, the particles go up and then fall down in a parabolic arc. Just simple, probably using velocity, v equals at or whatever. So it's real simple, it's really cool, and my next project is going to be to try and get the kernel to generate a fractal. The kernel is what runs on OpenCL. It's actually a special language that loads onto your graphics card and runs on the graphics card. So I'm going to show you a little bit. The cat command just prints out what's in a file. So all these ones called .cl, those are the shaders, or the kernels. Shader language is a little different. It's a lot simpler if you have a less modern computer. You need way fewer libraries. That's a language called GLSL, Graphics Shader Language. There's also a pretty cool Python wrapper for that, actually. Game of life example. So if you want to look for something like that, I definitely would recommend this website. It's pretty awesome. I also have a video of that available, and I'll link that at the end of this video. I've got it running on my machine. It's very neat. So you'd want to use his GLSL wrapper class for Piglet, as you can see. Piglet is a fast system. Anyway, that's about it. So yeah, I'll just show you what the CL kernels look like. They're very C-like, but they're not that long. As you can see, here's my cat CL command. So everything from this point on down is the OpenCL kernels. It's very C-like. You know, it takes a couple of arguments, has some floating points, floating point arrays, and then does some simple operations on them. So that's it for this video. Hope you enjoyed.